Good afternoon, all. Am I audible? Uh, of a system that is described by difference equation, and it is dependent output yn is dependent on previous sample of output. Okay, so yn is ay of n minus 1 plus xn. So this represents one difference equation. Okay, so, and only one previous sample of output is taken. That's why it is called first order difference equation. Now, we have explained the general difference equation as given by the last equation that summation ak yn minus k is equal to k is equal to 0 to m, and also the present and past output of the past inputs. So this equation describes present value of output and input and past values of output and input. Okay. So order of this equation is n, capital N, because we take n number of past samples of output. Now this represents, this is actually called difference equation, and it is linear difference equation. And the constant, the coefficients ak and bk are constant. That's why they are called constant coefficient difference equation. If these would have been variable like x or y, then it will not linear, or the coefficient are not constant, it is a variable, then that time it will be nonlinear difference equation. But we focus only on linear difference equation. Now we have seen, or just we have uh, discussed the method of finding the solution of difference equation. Not discussed, but some basic things that what are the different kinds of responses are there, like output response yn. You see, it is sum of two response. One is zero input response and another is zero state response. Okay. So zero input response means when no input is given, xn is zero. So output yn is totally dependent on the initial conditions of output, or only the past samples of output. Okay, that is called, so that time it is called uh, zero input response. And uh, when there is no initial condition, okay, previous output samples are zero, that time we get the output. If the input is applied, okay, then it is the output due to the input only. That time it is called zero state response. Okay, we have earlier discussed, in case of zero state response, so output is dependent only on previous samples of input, that is x. Okay. So keeping those things in mind, now we were proceeding for finding the solution of difference equation, and we have discussed that this is basically useful in case of IIR system. Okay, IIR system. Now There are two ways to find the solution of difference equation. One is the direct method and another is indirect method, that is using Z transform. Okay. So first we discussed using in a direct method. So in direct method there are two solutions. One is YH of n. So output is composed of two solutions, YH of n and YP of n. So it is similar like zero state response and zero input response. So YH of n is called homogeneous solution and YP of n is called particular solution. So here first primary criteria is that output is valid only for positive values of n greater than equal to 0. Here also n greater than equal to 0. So it is, you can say it is a causal sequence. Okay. Output is valid only for positive values of n. So first one is homogeneous solution, okay, and other one is particular solution. So now we discuss homogeneous solution. Okay. Homogeneous solution is somehow what it is. Say we consider no input is there, okay, in the general difference equation. Okay, that is this equation. Input part is 0 totally. Input part is 0, no x. So it consists of only y output. Okay. So only the output y part is considered, and this kind of equation has some format like you have seen in the case of differential, in the case of continuous signal. Okay, continuous signal we have solid for different formula for solution of difference equation. Similarly, in discrete case also we have some specific formula or method to calculate the solution. So YH of n is assumed as lambda to the power n. Lambda is a variable. Now if it is there n, then lambda h n minus k is n lambda to the power n minus k. Just we are replacing it. So from here we can write ak into lambda to the power n minus k. This is equal to 0. Okay. Now this dissolving in series, we get lambda to the power n plus a1 lambda to the power n minus 1. Since it is a summation, so it is a2 lambda to the power n minus 2 up to an lambda to the power n minus capital N. N is the order of the system. Now take lambda to the power n minus n common, so it becomes most highest power is lambda to the power n. So we get this one as this and this one. Okay. So in this you see that this part is not 0, lambda to the power n minus 1. So this part should be 0. Okay. This terms under bracket is 0. So it is called the characteristics polynomial of the system, and this has n number of roots because lambda power goes up to capital N, and these roots are defined as lambda 1, lambda 2 up to lambda n. And in this format we can write, since it is n number of roots, so n number of terms should be there. So lambda minus lambda 1, lambda minus lambda 2. Like this we can represent. Now these roots Okay, let me correct one thing. It is actually lambda 2. Okay? Lambda 2. So the roots can be real, complex, or some roots may be identical. Like lambda 1 and lambda 2 may be same, okay, or any other values. So in case of if the root in case the roots if the roots are distinct, mean all are individual values, there are no repetition, okay, all are different. So the solution is C1 lambda 1 to the power n plus C2 lambda 2 to the power n plus Cn lambda n to the power n, and C1 C2 are constants, okay, and those would be determined from initial conditions. Okay, that means previous values of output from the equation given. Then another case is repeated roots. Repeated roots are what? Here some roots may repeat, like lambda 1. Say lambda 1 roots repeats, okay, m number of times, capital M number of times. So we keep this thing at the power, okay, lambda minus lambda 1 to the power m. This is, say, if there are two roots, same roots, so lambda 1 lambda minus lambda 1 into lambda minus lambda 1, so it will be lambda minus lambda 1 whole square. So like that, and all other roots are different. So the solution for this is C1 lambda 1 to the power n as usual, but they will slowly, they will be multiplied by the time variable n, C2, then n lambda 1 to the power n, then n square lambda 1 to the power n, and it will go up to n to the, so here n to the power 0 we can say, here n to the power 1, here n to the power 2, like that it will go up to m minus 1, and others will remain same. It will be clear when we will see some example. Okay. Now next we take one example of homogeneous solution. Okay. So you see that we have seen zero input response. That means when input is 0, that time what is the output? And that was also termed as natural response, and it also can be called homogeneous solution or response. So let us take one example, yn minus 3 yn minus 1 plus minus 4 y of n minus 2. Okay. So the homogeneous solution to the power n. So in place of yn, we write lambda to the power n. In place of yn minus 1, we write lambda to the power n minus 1, and like that, lambda to the power n minus 2. So take common lambda n minus 2, and we will get the characteristics polynomial as lambda square minus 3 lambda minus 4. So if you solve it, you will get lambda is equal to minus 1, 4. So according to the formula for homogeneous solution, it is C1 lambda 1 to the power n plus C2 lambda 2 to the power n. And it is C1 into minus 1 to the power n plus C2. So putting the values of lambda 1 and lambda 2 here, so we get the homogeneous solution. This is called homogeneous solution, but not this is the response, actual response of the final output. So to get the final output, you have to calculate the value of C1 and C2. Okay? C1 and C2. How we will calculate C1 and C2? So we have to take the help of initial conditions. Okay? So you will get some set of equation. So C1 and C2, two unknown variable. So you have to get two two equations, two equations of C1 and C2, two equations of C1 and C2, so that you can solve C1 and C2. If it is variable 3, C1, C2, C3, then you have to get three equations, linear straight line equations for this one, linear equations of C1, C2 and C3. So how we'll get the equations of C1 and C2? So that can be obtained from this equation. Okay, putting the varying the values of n. Okay, so in one case n is equal to 0, that time you get the value. In another case n is equal to 1, another equation you will get. So now we get y, if we put n is equal to 0, that time it is 3 of yn minus 1 plus 4y of n minus 2. Okay, so where we are getting this? Uh, mm, from the difference equation 2.4.21. Okay, we get n is equal to 0. So we write these terms, we take the right hand side. So it becomes right hand side, it becomes y of 0, 3 is equal to 3y of minus 1 plus 4y of minus 2. Similarly, y1 is 3y0 plus 4y minus 1. So we get 3 of, we put the values of y0 over here. So you get this and this equation. Okay. So it is equations of y minus y1 and y minus
Excuse
y.
me, sir.
Yes.
Sir, slide is not visible.
Okay. Now is it visible?
Yes, sir. Now it's visible, sir.
So till what side it was visible?
In this
Sir,
slide,
it
sir.
just.
Huh?
Yes, sir.
This was visible.
Yes, sir.
Okay, fine. So, so we are getting that we are representing output samples y0, y1 in terms of previous samples y minus 1, minus 2, and these are initial conditions y minus 1 and y minus 2. Okay. Then uh, then now here homogeneous solutions that we have got. Okay, this is actually y0. Now here you put n is equal to 0. Okay, so you will get y of 0 in terms of C1 and C2. Y of 0 in terms of C1 and C2, and you have to get y of 1 in terms of C1 and C2. So we are getting y of 0 C1 plus C2. Okay, because n is 0, so minus 1 to the power 0 is 1, 4 to the power 0 is 1. So y of 0 is C1 plus C2, and y of 1 is minus C1 and plus 4C2. Okay, these two we have got. Now, now you will get, now compare these two equations of y0, this is y0, this is y0, this is y1, this is y1. So C1 plus C2 would be actually equal to y3 of y1 plus 4 of y minus 2, and minus C1 plus 4C2 would be equal to this one. So writing here, we are getting this. Okay. So now it will be, it is easy to find out the values of C1 and C2, and they are coming in terms of the initial value states of the system y minus 1 and y minus 2. Those two may be 0, initial values may be 0, so or may not be 0. Okay, that depends on the statement given or problem or situation given. So therefore the zero input response of the system is now you follow this equation yh1 yhn or yn, that is c1 and c2, they are multiplied with this. Okay, so we are writing c1 in place of c1, we are writing this variable. In place of c2, we are writing these terms, and they are multiplied with the factors according to the equation obtained earlier. Okay. So and all these are valid for positive values of n. This is the assumption. Okay. Now if y minus 2 is 0, okay, that is past to past sample is 0 and just past sample is 5, then we get c1 as minus 1 by 5 into 5, so it is minus 1, and c2 as 16 by 5. Okay, so it is 16 into 5, 16. So we get the zero input response as minus 1 to the power n plus 1 and 4 to the power minus 1 to the power n plus 1. Okay, here since it is minus 1 to the power n, okay, minus 1 to the power n, so minus 1 is there, c1, so minus 1 will be multiplied again, so it is minus 1 to the power n plus 1, and similarly c2 is 16, so 4 to the power n into 16, 4 to the power n into 16 means 4 to the power n into 4 to the power 2, okay, into 4 to the power 2, that means 16, so it is 4 to the power n plus 2. Okay. So this is the zero input response, because we have not given the input x, we are only having only the output, last output or initial samples y of minus 1, that is equal to 5. So the output will behave like this. Okay. So now I hope you have understood it. Have you understood? Shashwat, have you understood?
Yes, sir.
Okay. Then let us do some exercise. Okay. It is my handwritten notes. Okay. You can see that find the natural response of the system described by difference equation y of n plus 2yn minus 1 plus y of n minus 2, that is equal to xn plus xn minus 1. Okay, with initial conditions y minus 1 is equal to y minus 2 is equal to 1. Okay. So we have to get the natural response. So natural response means what? It is zero input response. Okay, zero input response. So that means xn is 0. Okay, xn is 0. So this equation becomes y of n plus 2y n minus 1 plus y n minus 2, that is equal to 0. Okay, this is equation number 1. Say. Now the homogeneous solution is of the form, then it is lambda to the power n. Simple method, you have very much familiar with this method. So now it is lambda to the power n plus this one plus this. So we will get lambda 1 and lambda 2. Okay, both are same. Lambda 1 and lambda 2 both are same. So according to the formula, it should be C1 C2 n into minus 1 to the power n. Okay, minus 1 to the power n is lambda 1 because it is lambda 1. Or simply it is C1 to the into minus 1 to the power n into C2 into n to the power, minus 1 to the power n. So now next step is you have to find the values of C1 and C2. How we will find the values of C1 and C2? Can anybody tell? How we can find the values of C1 and C2? Samriddhi, can you tell? So how we will find C1 and C2? From the equation given. Just putting the values of n is equal to 0 and 1. C1 C2 मतलब दो बार दो इक्वेशन चाहिए C1 and C2 का. So दो इक्वेशन कैसे मिलेगा? आउट जो इक्वेशन दिया हुआ है हम लोगों का उससे ही मिल जाएगा. तो एक बार दो बार n का वैल्यू चेंज करेंगे, एक दो बार n का वैल्यू लेंगे, एक n इज इक्वल टू 0 और एक n इज इक्वल टू 1. तो उस तरह का लेने से क्या होगा, यहाँ से y0 is plus 2y minus 1 y minus 2. सो यहाँ से मिल जाएगा y0, जब y minus 1 और minus 2 का वैल्यू दिया हुआ है, सो यहाँ से मिल जाएगा y0. सो यहाँ से वे भी साथ साथ में देख सकते हो कि n अगर 0 करेंगे तो डायरेक्टली y0 इज इक्वल टू cn मिलेगा. c1 इज इक्वल टू y0 है, क्योंकि ये टर्म n इज इक्वल टू 0 करेंगे तो वैनिश हो जाएगा. तो हम यहाँ पे डायरेक्टली लिख दिए c1 इज इक्वल टू -3, y0 इज इक्वल टू c1 इज इक्वल टू -3. और यहाँ पे क्या किए, यहाँ पे वही चीज रखे, y0 का वैल्यू दे दिए -3 और y1 का वैल्यू मिल गया. सो y1 का वैल्यू मिल गया मतलब है y1 इज एक्चुअली -c1 -c2 अगर n इज इक्वल टू 1 है, n इज इक्वल टू अगर 1 है तो -c1 -c2 हो गया इज इक्वल टू y1. सो इट इज 5 हो गया. c2 यहाँ से मिल जाएगा -2 हो जाएगा. नेचुरल रिस्पांस क्या होगा, c1 प्लस c2 -1 टू द पावर n ईच. सो यहाँ से -3 -1 टू द पावर n -2n into -1 to the power n. Or since it is valid for n greater than equal to 0, because the homogeneous solution is valid only for positive values of n. So we have to multiply this one with causal sequence. Causal sequence is u of n. Okay, causal sequence के साथ multiply हो गया. अच्छा, ये हो गया. अब और एक पार्ट है, और एक पार्ट क्या है? पर्टिकुलर सॉल्यूशन. सो होमोजेनियस सॉल्यूशन हो गया जब इनपुट 0 है, तब आउटपुट क्या है. सिमिलरली अगर इनपुट है तब क्या आउटपुट है? उस टाइम इनिशियल कंडीशन रह सकता है, नहीं भी रह सकता है. So in that case, let us assume that for that particular solution is what it is. It is also it follows some set of formulas. So this is your equation. Okay. So now अगर इनपुट एक कांस्टेंट है तो पर्टिकुलर सॉल्यूशन इज आल्सो वन कांस्टेंट बट डिफरेंट. अगर इनपुट एक सिंपल कांस्टेंट एंड मल्टीप्लाइड विथ सम एक्सपोनेंशियल फंक्शन a into m to the power n, that time the output is constant, different constant, but it is same exponential function m to the power n. Okay, and other formats are there. I am not discussing now. That is not much important. Now here determine the particular solution of the difference equation when input is 2 to the power n. Okay. So in that case, particular solution would be, it is 2 to the power n. So assuming that it is multiplied with 1 into 2 to the power n, 1 is constant. So for that we assume different variable, different constant k in the output, and it is multiplied with same input function 2 to the power n. So particular solution is now k into 2 to the power n into un, and at the same time, okay, this is the relation. So at the same time we write the other terms y n minus 1, y n minus 2 and xn. So put those values. Once we get yn or ypn, you can calculate yn minus 1 by just putting n is equal to n minus 1. So 2 to the power n minus 1, u of n minus 1, because it is delayed. Okay, n, it is causal sequence n, so you should multiply this with step function. Similarly, this is multiplied with step function with delay. No issue. Then it is simple 2 to the power n un. Okay, the input is xn is equal to 2 to the power n, but since it should be causal, so we multiply this with un. Okay, now how we will calculate the value of k? K is now here we can evaluate these equations for any n greater than equal to 2, because this from this value, okay, all the functions are existing, okay, or non-zero for n greater than equal to 2, because it is before that this function is 0. Other maybe there may not be there, but this is the most delayed function. So none of the term values for n greater than equal to. So we get it as n is equal to 2. So 2 to the power 2, it is 4k, 5 by 6, then n is equal to 2, so it is 2 only. and it is 1 by 6k, and it is 2 to the power 2, that is 4. So from here we get k is equal to 8 by 5. So the particular solution is 8 by 5 2 to the power n. Okay. Now, so we have seen the methods for calculating both homogeneous solution and particular solution. Now, to get total solution or total response, you have to add these two individually in situation where it is asked that to find total response or to find total solutions, like that. And when both inputs are present and initial conditions are present. So we will see that example. Just go through this line. Since the particular solution does not give the actual output, we have to consider both homogeneous solution and particular solution to calculate the forced response, okay, or total response, like that. So we are taking same example to understand this, but with some initial condition. Okay. So and some input, different input. So the same equation, difference equation, yn plus 2yn minus 1, yn minus 2 plus xn, xn minus 1. That is the same equation. Okay. You can see in the uploaded file also. So we get those values. See, minus 1, minus 2, we are earlier examples we are taking. Now input is now different, half to the power n. So we get the particular solutions and we get the values of k as given. So we get the values of k as 1 by 3. Okay, and particular solution is this. So forced response or total response is yhn plus ypn. So it is this one. Okay. Now in this equation, you have to find C1 and C2. You have to use the initial conditions. So we put y0, it is equal to C1 plus C3, and y1 is this. And from difference equation, we get from the difference equation is this one. So we get, putting the values of initial conditions as 0. So we get y0 is equal to 1. Okay, y0 is equal to 1, and for another value y is equal to n is equal to 1. Okay, I am not writing here. So this one is y1 is equal to 1 by 2. So this thing we use as C1 plus 1 by 3 is equal to 1, as y0 is equal to 1. And for the second equation, that is minus C1 minus C2 plus 1 by 6, that is equal to y of 1. Y of 1 is minus half, so it is minus half. So we get C2 is equal to 0 from here. Okay. C2 is equal to 0. So we get the final solution as 2 by 3 minus 1 to the power n plus 1 by 3 into half to the power n. So we have one problem given to you. Just try to solve this. Okay. And already it is solved. So you solve it by your own, this problem. Okay. And submit it in the chat box by today. This problem already is given, and although it is given, still you have to find it and do the exercise. Okay? And you have to submit it by today. Okay? And the other, and also this one you try to do. Okay? This one we try to do. this exercise. And the additional topics is there. I will not show it, explain it, because some other some additional things that are not in the syllabus. Okay. So I am not going to discuss this, but if you find interest, then you can see it later on. So is there any doubt? This was the thing that I wanted to discuss today. From my side, it is finished. And if you have any doubt to understand this method, you can tell me now. I am available now. Okay. Or if you want me to explain it again, then I can again explain it. There is no issue.